Good afternoon.
Good afternoon.
So how's everyone today?
Pretty good.
So since I didn't see you yesterday, did anyone do anything amazing over the weekend? Nothing? Well, let's see. It looks like we've got everybody here, so that's good. I decided to, since I had asked you to for the Moodle Day to come in and do a quiz, and y'all did that. So I went ahead and gave you attendance points for yesterday as well. So even though I didn't quote unquote take attendance, I could tell that you did, you took the quiz like I asked. So I went ahead and gave you the points for that. Let's see what else. Which I guess it was a good thing that we'd set up to have a Moodle Day yesterday because we lost power in Holbrook. And so I wouldn't have been able to broadcast anyway. So that worked out pretty nicely. The other thing is that I'm kind of hoping, since you all showed up and took the quiz yesterday or whatever, what I'm thinking about doing is on President's Day, which is the 17th of February. What I'm thinking about doing is having that be a Moodle Day. So, because I don't think any of you have school that day, right? But NPC has class. And so if we go along with the NPC schedule, then you'd have to come and we'd have class that day. So what I'm thinking about is making it a Moodle Day and making the Moodle quiz that day be one that maybe you could even take it home. So you wouldn't even have to come to school, for me anyway. If you have another NPC class, you might have to come. But I was thinking then you could take your quiz while you're in your jammies, have it open for a while. And then, you wouldn't have to worry about coming in. So,
Mr. Strong, that
yes.
sounds amazing. You should do that. I think we all agree.
All right. Well, good. Well, I'm kind of working toward that now, and like I said, I felt pretty good about that everybody was able to come in and do that yesterday, and so that actually kind of factored into my plan there. So I'm going to work toward that. So we'll as we get a little closer, because I know if I was in your shoes, I wouldn't want to come to school for just that one class, even if it is an amazing class. You know what I'm saying? So, okay. So the next thing is, okay, so the videos I've got loaded up since last Thursday, so we're all caught up. But there's been some issues with the videos in that they haven't been uploading to the server. They haven't recorded right. Some of my classes didn't get recorded at all. And so anyway, so I just kind of want to let you know, because I really wanted a quicker turnaround this semester. But they're doing what they can to get them available. But I'm all caught up right now. And this class is actually recorded every time. It turns out yesterday, even if we would have had a class, it wouldn't have recorded anyway. And one of my trig classes didn't get recorded. But we'll just deal with it. So I'll let you know if there's other issues involving the recordings. Otherwise, we'll keep doing the best we can.
Mr. Strong.
Yes.
We play Holbrook today.
In basketball.
In basketball? Yeah,
Yep.
I actually told one of my Holbrook students, I said, you need to look out for that Chloe. She's
Did
like,
you?
I might have mentioned your name, but they were talking, didn't you beat them last time?
No, it was a
Boys
close.
did.
Yeah, our boys won, but
Oh, the
our girls,
boys,
it was
so
a
you
very
split-
close game.
Okay, so that was it. So yeah, they're all excited. The boys are all excited to get back and beat the boys. So anyway, are you excited about that game?
I'm very excited. It's going to be a good game.
That's awesome. That's
Yeah.
awesome. Well, you'll have to let us know how things went. Okay. Anyway, that'll be great. Well, let's go ahead and get started. We're working on 7.5 now, and I really like this lesson because, for the most part, it's pretty easy compared to some of the stuff that we've done. It always feels like a breath of fresh air when we get to this. I don't know. Maybe you won't feel that way. You'll have to let me know if you like this lesson or not. So let me go ahead and get started. This is called Indeterminate Forms and L'Hopital's Rule. It looks like La Hospital or something, but it's pronounced L'Hopital. And that's just the name of the guy, the Frenchman that came up with this. Now, if I were going to write a book, a calculus book, the title of this section for me would be Finding Limits Using Derivatives. Okay? And so the reason why it's in this section is because how we use it is going to involve transcendental functions. Okay? All right, so here we go. So L'Hopital's rule basically says that if you have the limit of a quotient, f of x over g of x, then what you can do is take the limit of, and then you take the derivative of the numerator over the derivative of the denominator. Here, I'll come back to this. Okay. So, let me just state one thing that's great about this is you're not using the quotient rule. You don't use the quotient rule when you're taking the derivative. You're taking the derivative of the numerator and the denominator separately. Okay? All right, let's go through an example here. All right, so let's say I want the limit as x approaches 0 of 3x minus sine x over x. Okay, so the first thing you do when you're trying to do these limits is, and really almost any limit that we did back in chapter 2, the first thing you try to do is plug in the number. And if you plug in the number and you get an answer, you're done. Okay? So everywhere there's an x, just plug in 0. So you take the limit of, as x approaches 0, so you're going to plug in 0, so 3 times 0 minus the sine of 0 over 0. Well, 3 times 0 is 0, minus the sine of 0 is 0, over 0. Well, 0 over 0 is what we call an indeterminate form. Okay? So that's part of the title for this section, the top of your page, indeterminate form. So what that means is that we don't know what the answer is. Could be 0, could be infinity, could be 12/5. We don't know. It's indeterminate. So what we do is when we get 0 over 0, just write IF. Now when you get IF or an indeterminate form, that's when you can use L'Hopital's rule. So L'Hopital's rule, so then to show that I'm using L'Hopital's rule, I just put the L'H for L'Hopital. And then I'm going to now take the limit as x approaches 0, and I take the derivative of the numerator, which is 3 minus cosine x, and the derivative of the denominator, which is 1. And so what L'Hopital's rule does is it simplifies those functions considerably. All right, then you plug in 0 again. So the same number you're plugging in, so you'll get 3 minus the cosine of 0. Well, the cosine of 0 is 1, so 3 minus 1 is 2. And so that's the final answer. Okay? Okay, so see if you can do practice 1 on your paper. All right, Aiden. When you get the answer.
Is it 1/5?
Is it 1/5? No. So let's go through it. So first you plug in 0. So you get the sine of 0 over 0. Well, the sine of 0 is 0. 5 times 0 is 0, so that's an indeterminate form. Okay? So again, we don't know the answer now. But now we can apply L'Hopital's rule. So we take the limit as x approaches 0 up. Okay, so what's the sine of 5x? What's its derivative? Say again? What's the derivative of sine of 5x?
5 cosine x.
5 cosine 5x. So the derivative of sine of blob is cosine of blob, but then you have to multiply by the derivative of the inside part, the chain rule. So you're going to get cosine 5x and then times 5, which I just wrote out in front. All right, then what's the derivative of 5x?
5.
5. Now, before you plug in again, you always want to look to see if you can simplify. And so in this case, the 5's cancel. And so you just get cosine 5x. I would cancel the 5's. Well, and then you plug in cosine of 5 times 0. Well, the cosine of 0 is 1. So your final answer is 1. Now, does anybody remember way back in September, the one limit I asked you to memorize? Does anybody remember that? So the one, oh, go ahead, Jordan. You going to say something?
Was it sine theta divided by theta equals 1?
Yes, as theta approaches 0. And so that's what this is if you think of your theta as 5x. So I actually never proved that for you. I just told you to memorize it. But it's actually because of L'Hopital's rule that it works. Okay? So the sine theta over theta as theta approaches 0 is 1. And so you could actually, if you remembered that, you could just go right to the answer. All right. Okay, now, if we get 0 over 0, and then you use L'Hopital and you plug in and you get 0 over 0, we can keep doing it. We can keep using L'Hopital's rule and differentiating until one of the derivatives, when one of the derivatives is different from 0, then you get to stop. But as long as you have 0 over 0, you keep using L'Hopital's rule. Okay? So we stop differentiating when we get something other than 0 over 0. All right? So let's look at this one. So step 1, you plug in the 0. So we get 1 minus cosine 0 over 0 plus 0 squared. So the cosine of 0 is 1. So we get 1 minus 1 is 0. In the denominator, we get 0 plus 0 is 0. So an indeterminate form. So now we use L'Hopital's rule, and we take the derivative of the numerator. The derivative of 1 goes away, 0. The derivative of negative cosine x is positive sine x. The derivative of x is 1. The derivative of x squared is 2x. So now we plug in 0 again. So we get the sine of 0 over 1 plus 2 times 0. So the sine of 0 is 0. 1 plus 0 is 1. So we can stop because of the 1 here. We don't keep using L'Hopital's rule. In this case, the answer is 0. Okay? You only keep using L'Hopital's rule when it's 0 over 0. If you have 0 over something else, the answer is 0. If you have something over 0, then the answer is infinity or negative infinity. Okay? All right, go ahead and try practice 2. All right, Joey, I choose you.
I got 12 over 7.
12 over 7 is correct. Good job. So first you plug in 2 and you get 0 over 0, indeterminate form. So then you apply L'Hopital's rule. The derivative of the numerator is 3x squared. The derivative of the denominator is 4x minus 1. Plug in 2 again, and you get 12 sevenths. Okay, so great job. Any questions on that? Okay, so L'Hopital's rule also applies to one-sided limits. So if you're approaching a number from the left or the right, you can still use L'Hopital's rule. You do it just the same way. Okay, so if I'm approaching 0 from the right, you still plug in 0. The only time you have to worry about the plus or the minus is if you end up getting infinity, and then you look at the plus or minus to see if it's positive or negative. Okay, otherwise you just treat it the same way. So plug in 0, and you get sine 0 over 0 squared. So 0 over 0, indeterminate form. So now you use L'Hopital and you say, okay, the derivative of sine x is cosine x. The derivative of x squared is 2x. So now you plug in 0 again, and you get 1 over 0. So whenever you have a constant over 0, the answer is infinity or negative infinity. So here you have to look at the sign. See, if as x approaches 0 from the right, so slightly positive values, well, either way, cosine is going to approach 1. But here, as x approaches 0 from the right, this value is always going to be positive. So you'll have 1 over a positive number, so it's positive infinity. If we were approaching 0 from the left, well, let's just see is that the problem here? Okay, so if we're approaching 0 from the left, then what would our final answer be? This is practice 3. So. All right, David, what would the final answer be if we approach 0 from the left?
Yeah.
Say it again.
Yes. Okay, negative infinity.
Negative infinity. Yeah, because see cosine is always approaches 1, so that's positive. But if we're plugging in a value slightly less than 0, then this value is going to be negative. So it'll go to negative infinity. Okay. All right, any questions on that? All right, so you might say, is 0 over 0 the only indeterminate forms? And the answer is no. That you have 0 divided by 0, infinity divided by infinity, infinity times 0, infinity minus infinity, let's see, I think
Mr. Strong,
yes.
we have an issue. Our board glitched out and we had to restart the system, and now we can't see the other board. So we can see like you in the other classes, but we can't see the board with all the information on it.
Can you see it little behind me?
Not really. The frequency of the camera and the frequency of your screen match, so it flickers anyways, and then we're having like slight internet issues, and so it's just glitchy and hard to see.
Can the other school see everything okay?
Yeah, we can see just fine.
Okay.
So it's
I will call
probably
Mike back.
yeah, you better call him back. Just kind of for this, so for the notes, I'll just tell you what to write, and then as we go through and then you might just on the examples, just kind of do the best you can do. But then on the practice problems, make sure, because you have those written down, make sure that we get those right, so that if there's an issue there, then we'll go through. So the answers to the practice problems, you need to listen carefully, because I want to make sure you get those right. So did you get these indeterminate forms, or do I need to go through these again?
You're going to need to go through them again.
Okay, so 0 divided by 0 is the first one. Oh, we lost them altogether. Well, they might just have to. Well, we'll figure it out. Maybe they'll watch the video.
We
Okay.
got restarted and we got the board back, Mr.
Oh,
Strong.
wonderful.
So we can see it. Can you give us a moment to
Okay.
write it down?
Sure.
Thank you.
You bet.
Mr. Strong,
Yes.
did you ever look at who was like first chair, like number one or
Oh,
whatever?
yeah. So, thank you for reminding me. So, the first chair for the first semester was, in fact, Chloe. So, good job. So you were the highest in this class. Okay. Now, I actually looked at, and then if we, there were kind of two things that were unique about the grades between this class and the Holbrook class, because I was comparing them. Holbrook actually had the highest overall average of the two classes, but you guys had only A's and B's. Holbrook there was a student that got a C, but I was actually happy because when all my students get college credit, that's kind of my goal at the beginning, is I want all my students to get the college credit. So anyway, yeah, congratulations, Chloe. That's better than being like a tournament MVP. You're like calculus.
Oh yeah, calculus. Skylar, I think, had a higher grade than me though. Is that?
Yeah,
wrong?
what?
I think Skylar had a higher grade than me.
Yeah.
Overall?
Yeah.
Well, maybe I checked it. Maybe I looked at it. I'll double check.
Well, it's an honor anyways.
It's all right. Well, it's good. I was really, really happy. So, but and both of you, well, actually, like I said, I was really happy with everybody's grades in Calc 1, and because that really helps you in this class too. So, okay, well, let's go on to the next example here. All right, so the first thing we do is we plug in the pi halves. Okay, now let's make sure that you understand, remember how to do like secants and stuff. Okay, so in my mind, when I'm calculating the secant of pi halves, then I just remember it's going to be the reciprocal of the cosine of pi halves, or 90 degrees. Okay, so the cosine of 90 degrees is 1. So, no, it's 0. Cosine of 90 degrees is 0. So the reciprocal of that, 1 over 0, would go to infinity. So that's why we get an infinity there. Okay, the tangent of pi halves. The tangent is the sine over the cosine. Since the cosine is also 0, then we have 1 over 0, which is infinity, plus 1, which is also infinity. So there we get an indeterminate form. So we can use L'Hopital's rule. So next, we do the derivative. So the derivative of the secant is tangent. So, the derivative of secant x is secant x tangent x. The derivative of tangent is secant squared x. Now, before we plug in again, after you use L'Hopital, you'll always want to look to see if you can simplify algebraically. So like here, we can cancel one of the secants. So then we're left with tangent x over secant x. Now, so when I have trig functions like that, instead of trying to plug in, what I always like to do is see if I can cancel the trig functions by rewriting them in terms of sine and cosine. Okay? So tangent is sine x over cosine x. And then secant, 1 over the secant is the same thing as the cosine. It's the reciprocal. And so now we can cancel the cosines, and so we just end up with sine x. And so then we plug in pi halves, and the sine of pi halves is just 1. So that's our final answer. All right, what was this example for? All right, so go ahead and try practice 4.
Negative 2/3.
Professor Strong, I think you're on mute.
Thank you. All right, so you had 2/3. Let's see why it would be negative 2/3.
I said negative 2/3.
Oh, you said negative 2/3. Okay. All right. So, well, did anyone have a question on that? Would like me to go through it? Okay. All right. So the indeterminate form, infinity times 0. Now, this is like a trick to use L'Hopital. This is an algebraic trick here in the notes. Sometimes we can use an algebraic substitution, h equals 1 divided by x. What this is, it's called introducing what's called a dummy variable. And a dummy variable here, it makes it so that we can algebraically manipulate it, and we force a fraction. So like instead of multiplying, we divide by the reciprocal. And so then if we force a fraction, it makes it so that we can use L'Hopital's rule. Because you can only use L'Hopital's rule if you have a fraction. And so this algebraic trick is where you do a substitution with the reciprocal. Okay? All right. So let's say that we want to take the limit as x approaches 0 from the right of the square root of x times the natural log of x. See, this is, when you look at this, when you plug in 0, square root of 0 is 0, natural log of 0 goes to infinity, all right? It actually would go to negative infinity. So it's an indeterminate form. The problem is that it's not a fraction. So you can't use L'Hopital the way that it's algebraically written because it's not f of x over g of x, and take the derivative of each. So what you do is, so to force it into a fraction, you think instead of x times y, think of it as x divided by 1 over y. Or in this case, it's going to be natural log of x. So instead of times radical x, it's divided by 1 over radical x. All right? So now, by doing this, now we can take the derivative of the numerator and the denominator. So now the derivative of the natural log of x is 1 over x. Now this derivative here, I just kind of go to the side and work that out because it's a little more complicated. So this is x to the negative 1/2. So the derivative, you'd bring the negative 1/2 in front, and then it's x to 1 lower power. So x to the negative 3/2. So negative 1/2 x to the negative 3/2. So now, before you try to plug in, though, simplify this algebraically. See, here you have a complex fraction for 1. That's not cool. So you would say, okay, 1 over x times divided by negative 1 over okay, so negative 1 over 2x to the 3/2, using the elevator rule on that. And so when you have a fraction divided by a fraction, you can multiply by the reciprocal. So that's how this becomes negative 2 times 1 times x to the 3/2 over x. And then the x to the 3/2 over x to the first, you subtract the exponents and you just get x to the 1/2. So negative 2x to the 1/2. So now you plug in 0. Square root of 0 is 0 times negative 2 is 0. Okay? So So you end up with 0 as an answer, and that's fine. But the algebra tricks here in this problem were doing the reciprocal thing and then getting rid of the complex fraction by multiplying by the reciprocal. So 2 algebra tricks here really is what did it. All right, so let's see if you can do the next one. Practice 5. All right, so Jordan, when you've got it.
I got infinity, but I'm not entirely sure I did it right.
Okay, so when you plug in infinity, you get infinity over the sine of 1 over infinity. 1 over infinity goes to 0. So what's the sine of 0?
It's 0.
0.
I didn't.
So that's an indeterminate form. Okay. So, but as it is, you can't use L'Hopital because you don't have a fraction. So then how do you rewrite it?
Can I change my answer then? Because
Sure.
I didn't know sine of 1 over infinity turns into 0, or I had forgotten that. So I went and I redid that later on and I got 1.
Okay. So how can you rewrite it so that you can apply L'Hopital's rule?
So you move 1 divided by x to the bottom.
Right. So and so instead of times x is divided by 1 over x. Okay. Now, can you just say, oh, this is the limit that I memorized. The sine of theta over theta. Is that always, that's 1, right?
That's only when the limit's approaching 0, right?
Right. It's only when it's approaching 0. But we're actually pretty close here. It's only when it's approaching 0. So this is, we plug in infinity. So the sine of 1 over infinity, that goes to 0. The sine of 0 is 0. 1 over infinity is 0. So this is still an indeterminate form. But now I can use L'Hopital. All right, so the sine of 1 over x, the derivative of that is the cosine of 1 over x times the derivative of 1 over x. So now I came over here to the side and said, okay, the derivative of 1 over x, or x to the minus 1, is negative x to the minus 2. So that's where that comes from. Well, then the derivative of 1 over x is also negative x to the minus 2. So that whole thing is going to cancel. The negative x to the minus 2 is going to cancel. So what we're going to end up with is just the limit as x approaches infinity of the cosine of 1 over x. Well, so as we plug in infinity, 1 over infinity is going to go to what?
It's 0.
And then what's the cosine of 0?
It's 1.
1. So you're right. The final answer is going to be 1. Now, okay, so let me just teach you a little trick here. And if you understand what I'm about to say, great. If you don't understand this little trick that I'm about to show you, don't worry about it, okay? But this might help somebody. Okay, so let's say let's say that h is 1 over x. Okay? If x approaches infinity, then h approaches what?
0.
0.
So this right here, I could actually rewrite as, well, you know what? Let's just go ahead and use theta. I'm going to use theta. Now let's keep it at h. Okay? But see, that limit right there becomes the limit as h approaches 0 of sine h over h. So I actually knew it was going to be 1 up here. Even though I said that the one that we memorized doesn't work there, it actually does. If you do the reciprocal and you change the variable, do that dummy variable swap, it actually works there. So, okay, okay, so let's see. Let's do one more here before we run out of time. Oops, didn't mean for that. Okay, so if there are fractions, try to combine them. Okay, so when you do, like here, when you try to plug in 0, see, you'll end up getting infinity minus infinity, and so that's an indeterminate form. So you have to get a common denominator and then try to plug in, okay? So what I want you to do for Thursday's class is I want you to try practice 6. So you're going to get 0 minus, or infinity minus infinity. But before you can do L'Hopital, you got to combine those fractions together. So get a common denominator, combine them, then try again. Okay. Oh, tomorrow is a quiz. It's on 7.4. Mogyan, are we doing, what time are we doing yours? At 10?
Yeah, 10.
And then everybody else, the hour before class at 1:50 to 2:50?
Yeah.
Yeah? Winslow?
Can we take it at 9 in the morning?
At 9 in the morning?